Okay, let's do the thing. So we died at invalid instruction 40, which I believe matches our expectations. If we look at the trace, which is this one, we got a 20. Oh, we should have hit an EA instead. So JSR is wrong somehow, or it even is a 40. So we've got something wrong with our stacky, pushy stuff. Oh, well, I didn't update the program counter at any point, so I suspect I'm doing that wrong. How about that? Where's my 6502 reference junk? There it is. JSR. Copy low address byte to PCL, fetch high address byte to PCH. Aren't I doing that? What does this have to say here? Push, push, fetch to ABL. But I'm not fetching to... Wait, why am I even fetching to ABL? That doesn't really make sense, does it? Oh, this has us going past the JSR? Hang on, I'm confused. Okay, so we definitely have a no-op in here. Welcome back, everyone. Thanks for showing up again. Appreciate it. Gonna try to do 2 more hours, get as much of the CPU implemented as I can, and then I'll probably do like shorter 1 hour, 90-minute type streams for the week. Because as much as I am enjoying this challenge, I got other stuff to do in my life, and especially in my job. If any of you are not from the emulation dev Discord, please let me know, just because I would like to see what anybody else has to say. Okay, so we add them in reverse order, which does make sense. So we do fetch to ABL, which is what I said. Then we do a no-op. Then we do push PCH, push PCL. We do write X. I don't think that's right, is it? Then we do fetch and copy, fetch and decode. No, yeah, this is not right. I don't know why this is still here. It's fetch. Okay, so we fetch the low address byte increment PC. So this should actually be a fetch to the IDL, the input data latch. And then we want to fetch and copy should be the rest of that, right? Should fetch the rest of that stuff. So I think that's really the problem, is that we didn't have a fetch to IDL in here, like we did for jump absolute. See if that helps. There we go. Now we're dying on EA, which is what we should be dying on. EA is very easy because it's a no-op. Result EA no-op as usize equals vec microphone no-op microphone fetch and decode. So that should handle that. Yep. 38. Yeah, this one. Yep, so EA 38 is sec, whatever that means. Set carry flag, huh? Okay, so that just changes S. If I recall correctly what the registers are. No, P. P is for processor. I've got that opened up in here somewhere, I think. CPU power up state. Where's the CPU registers? Dang it. Ah, here we go. Registers. I did look at this, I swear, like 2 minutes ago. I had a thing that told me this. But I guess whatever. I'll find it in here. I just need to know what bit of the status register is the carry flag. Here we go. Okay. Negative is 8. 80 overflow is 40. 20 is unused. Break is 10. 8 is decimal. 4 is interrupt. 2 and 1 is carry. Okay. So, again, we're going to do const set sec is a 38. It has no arguments, which makes it, again, pretty simple. Just going to go ahead and do this. There is, instead of a no op, going to be a set flag. Let's just make sure. Words, please and thank you. Let's just make sure there's nothing else going on. Okay, well. This is going to be in here somewhere. Stuff that messes with status registers. I mean, I guess it's just going to take 2 operations, right? It would seem very strange if it took more than that, but I'll probably just implement it that way. Okay. So all we have to do for this is set flag, flags C. Now we're just going to go ahead and copy this. Drive, copy, clone, debug, flags. We've got a bunch of other ones. Oh, and we actually want to repr U8 this one so that we can make them match what they actually are. And that'll be pretty easy. Back at it again at Krispy Kreme. I guess I don't really, I mean, I can just implement it in line. There's no real reason not to. Set flag, CPU underscore. Hey, Sai, how many instructions does the, or microops does the set condition code instructions take? Like, how does that work? Okay, and then I just need to add the actual flag. Set flag. Flags. I feel like that'd just be a single UOP. Yeah, that's what I went with as well. Expected fun pointer con closure. What? I do that like 100 other places. What did I do wrong, you little whiner? Fetch to your edge names. What a weird thing to be annoyed about. Alright, whatever. Oh, hey! Is that Russell? Thanks for stopping by, dude. How's it going? Regs.p. I still feel like S should be status, but whatever. Yeah, this is obviously wrong. Oh, I know what I'm doing that's wrong. Well, no, maybe I don't know what I'm doing wrong. How come you're mad at me that this is a closure? It's a closure in like 100 other places. I'm calling into? I'm very confused about why that's like an issue. Alright, well, let's just like match on flag, I guess. CPU underscore underscore CPU dot regs dot p or equal is that gonna work? No, because I forgot to close the thing. Okay, so that works. That's really weird. I don't understand why that was. If I just delete that and this, does that work? Oh, it's the braces. That's why. It needs to be inside of a brace. Some sort of coercion is happening. I don't really understand why, but. And now let's just make this flag, and we'll have all the flags implemented because that's really annoying. Are you kidding me? Alright, whatever. Just match it this way. I don't really know why that's not working. I have to ask someone who's better at Rust than me. But in the meantime, we should be able to get past that instruction, get to B0, which is in fact the next one, BCS. Sounds like branch on carry to stack, maybe? It's going to be my guess. Relative addressing. Branch if carry set, I bet, actually. Yep, branch if carry set. Relative addressing, cycles +2 +1 if branch succeeds +2 if to a new page. Okay. Hopefully this will go through that in detail. Fetch opcode increment, fetch operand increment, fetch opcode of next instruction. If branch is taken, add operand of PCL, otherwise increment PC. Fetch opcode of next instruction. If the branch was taken, I guess. Fix PCH if it did not change increment PC. The documentation is incorrect, ambiguous about the page cross. Penalty for branches. Okay. That makes sense, I guess. So what's the real story? +1 if branch succeeds, +2 if it's branching to a new page. That kind of makes sense to me. A branch is 2 cycles if not taken, 3 cycles if taken, 4 cycles if taken if page boundaries crossed. Okay, yeah, that makes sense to me. So basically, if PCH changes, that means we're on a new page because pages are 256 bytes. So that's what this is saying. And PCH may not be valid if branch is taken. So if branch is taken, this cycle will be executed. If branch is taken to a different page, this cycle will be executed. Which I guess means that we don't do the fetch in page 4. Right, so in cycle 4, we don't do this fetch, or maybe we do the fetch. Actually, that might matter. But we'll do it again if PCH changed. I'm not sure what fix PCH is supposed to mean, though. If PC and F is not equal to PC and F plus offset, do page cross penalty. Yeah, well. All right. This is another relatively challenging instruction. All right, so const branch if it's carry set is what again? B0. And so opcodes BCS. What we need to do is, all right, we fetch the operand and increment the PC. Doesn't say where to fetch it to, so I guess just to the IDL. We'll just do it that way, just for now. Fetch to reg names IDL. Fetch opcode of next instruction. Fetch operand. Does that mean it only has one argument? Yeah, bytes 2. Interesting. Okay. Guess that makes sense. What webcam am I using? It's a Logitech C270, which is like the cheapest Logitech webcam. Yeah, no problem. Okay, yeah, so that makes sense why it's relative then, because it's going to add to the PC. So let's just do fetch opcode of next instruction if branch is taken out of operand to PCL. All right, let's just call this branch relative, and it doesn't have any arguments currently. Oops. Branch relative, and then we'll actually implement this separately. CPU. I really need to delete these extra arguments. I say that every time. I'm actually just going to do it now because I don't know how to implement branch relative yet anyway, so this is a good time. Boop. 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 Jeez, I did this a lot, didn't I? Oops. Should have done it sooner before I made all these calls look like this. Oh well. Boop. 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 Hindsight is 20/20. That is true. Which I think this should be the last one, hopefully. Oops. Deleted too much, and then get rid of this. Are you gonna run? Okay, well, no. But for understandable reasons. All right. So this is an easy one to implement in this branch here because all we need to do is just branch relative. It's easy. What? Stupid thing. Okay. Go. Run. Blam. 18. Which is going to be totally wrong because I didn't actually implement this. Okay, so fetch opcode of next instruction. Okay, so that's easy. CPU.fetch byte, CPU.get PC. If branch is taken, add operand to PCL, otherwise increment PC. Okay, so when you said fetch, you actually meant get. If So yeah, okay. Let's make this take a flag, at least for now. And then maybe I will need to add like a flags unconditional, which would be fine. But that means I can't implement this as simply, which is fine. Oops. So we're going to match on the flag. And we're going to do CPU if CPU.regs.s and flag as U8 is greater than 0. So if we're going to branch, then add operand to PCL. Okay, so CPU.regs.pc plus equals CPU.regs. Or PCL, I guess. CPU.regs.idl, which is where we hold it. Otherwise, CPU.regs.pc plus equals 1. And I think the thing to do for the rest of this instruction is actually just to get rid of the other stuff, because we can always push more instructions into the queue. So I think what we're going to do is queue.pushFront microphone fetch and decode. All right, so that's the 2 branch or the 2 cycle version where the branch is not taken. And we are going to want to do okay, let's do this. Temp PC equals regs PCL as U16 plus CPU regs IDL as U16, and that way we'll get the full thing. If temp PC is greater than FF, regs PCL equals temp PC and FF. And also, we're going to add an extra delay. So CPU.Q.pushback, front microphone no op, and then fetch and decode. Sai, does anything interesting happen in that extra delay from the bank switch, or is it just literally a no op stall cycle? I don't know. Oh, that's what it means by fixed PCH. Because you add it to PCL. Okay, I see what they're saying. CPU regs PCH plus equal 1. Otherwise, equals temp PC, and we just add that. Okay, that got very complex very quickly, but I think it's correct. Except that it doesn't build, which is fine. Okay. Need to change all of this because I thought I had split the PC and I didn't. It's not equal to regs PC and fx00. Either way, we want to do regs PC plus equal, or not plus equal, equals temp PC. Not under regs. Should maybe change that, but whatever. You son of a bitch. It's a closure because it captures flag. That's why. So it's not going to help, but if I put move here. Yeah, I didn't think so. Okay, so that's what's the difference, is that because we're not matching on the flag, it becomes a closure that can't be coerced because it captures its environment. So this would be a really good chance to, this is an example of where having an argument into the function would actually be useful. Just after I deleted all the arguments to the functions. Okay, well, whatever, we're just going to get past it for now. So we only have one flag defined right now. Okay. Expected expression, probably just means I didn't, yeah, gotta get rid of that. There we go, choo 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 choo. You ended up at invalid instruction 18, is that correct? Probably not. So where's my answers? There we go. Oh, it is. You should hit another no op, which looks like I did. And then CLC. Cool. All right. And then we're going to go in here. We're going to do clear flag. Exactly the same, just backwards. Except that's not going to be right, is it? Help use not to perform bitwise negation. I knew you were going to do that. Okay. Oh, that's not supposed to be a double match. Clear flag. And then do. I see we're up to 11 viewers. Thanks everyone for stopping by. If any of you are not from the EmuDev Discord, please say hi. Okay, so instruction is going to be clear carry, which is literally just this, except for clear flag. And we need to give the name CLC, it's 18, go. Okay, instruction 90, that's not right. Maybe it is actually, because we've got 4C implemented, EA, set C, yeah, okay. Hi, Russell. Are you following what's going on? Do you have any questions? Do you want me to explain anything in more detail? I'm just assuming basically that everyone has been watching me the whole time, because why wouldn't you? Because I'm amazing, but. Branch if carry clear is exactly the inverse of branch if carry set, obviously. humble. I'm gonna need to take another pause to clean up in a second here because this is obviously getting a little bit silly. But I'm gonna get at least one of the branch clears implemented, and then I will hopefully have a good idea of what I want the design to actually look like. BCC is 90, I believe. Yep. 90. This is going to be branch clear. And then the branch clear implementation. Yeah, it's twoo. And not equal to 0. Or wait, is equal to 0. Okay. 4B. Did that go correctly? 90, 4C, EA, 18, 90, EA, A9. So no, that did not go correctly. For B, so I read this instead of. All right, well, what did I do then? BCC and branch clear. What went wrong? Set clear and then branch clear is supposed to grab 0, 3. I think I'm pushing instructions in the wrong order. I think that's what's going on. Nope, that's not what's going on. I'm gonna start printing the instructions when I pop them off the queue, and that will help me figure it out. This is the first instruction that I've implemented that didn't like work. Oh, hang on. I know what dumb thing I did now. Oh, no, maybe I don't. Okay. Branch clear, fetch and decode. So either the set clear is not working or the clear is not working because it's deciding not to take the branch, it looks like. Because it just calls fetch and decode immediately. Oh no, I guess it could just be branching within the same page, which actually it is doing. Alright. Colon colon sharp x, I think is what I want. And then we get IDL. And then we get, what's the next thing? I guess PC would be relevant, but S, IL, PC. Oops. Oop. Whoops. S is FD. I know what dumb thing I did. I've been using the stack register. Probably in all cases. Nope, just in the branches. Okay, there we go. Invalid instruction 40. Is that where I'm supposed to be now? Probably not. Yeah, so I broke branch set, which was always wrong. Apparently. You should print the PC alongside your UOPS. That's not a bad idea. Hasn't really mattered. Do you think I should do that when I fetch them or when I execute them? Or both? I love technology. I'd say when you fetch. Yeah, I was thinking the same thing. Oh, and I should change all of these to P's also so I can see what the hell's going on. P, P, P. At some point, it becomes worth it to implement more thorough debugging infrastructure. All right, let's just run that. Oh, because you are the CPU. Chugga, 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 chugga. Okay. So we fetch the IDL. We execute branch set. P is 34. IDL is 3. And then we fetch and decode with A, which actually seems like it's right, but is not. So we're here now because we're hitting this. So we're incrementing PC an extra time for some reason. And the reason we didn't see it before, or wait a minute, maybe we're not. Where was I starting? C737. So I was starting here. Yes, I'm incrementing it an extra time when it's empty. Or when it's not taken, when the branch is not taken. So if the branch is not going to be taken, that should be here. Oh, this is a branch set though. Is a fetch even happening here? No. So I probably don't need to do this. Because the next thing is going to be that. Yeah, okay. Because calling fetch, it will increment anyway. So we don't want to increment if the branch is not taken. And how does that compare to this? It says fetch operand, increment, fetch opcode of next instruction, otherwise increment PC. Oh, okay. No, what I need to do is I need to inline the fetch and decode step right here. Yeah, I somehow didn't think that was going to work. Fetch and decode CPU. And then we want to do the same thing here. Valid instruction A9. Is that what we're expecting now? Yep, load A. Okay, so that was the problem. So basically what happened there was if the condition is not taken, according to this document, you actually do the fetch and decode in cycle 3 of the instruction. So I'm guessing that the condition is checked actually in cycle 2 or something like that. I don't think this document is actually entirely correct in terms of like when, what happens where. But I think that what I did is just, if the branch is not taken, I just inlined the fetch and decode stuff so that it would be executed in the correct cycle. We wouldn't get an extra PC increment, and now we are making it past that point. So next is load A, which should be relatively straightforward because we already have it implemented for load X. And I would think that would be basically the same thing. Oh, except that it sets the flags. That's interesting. LDX is also supposed to set the flags, which I am not doing. So let's do that. I'm sure that will be tested shortly. That was in fetch 2 and read 2. Actually, no. Okay, I'm going to stop for a minute. I'm going to think before I act. I'm going to think about how to clean some of this junk up. There's obviously some stuff that should be rolled in together that isn't going to work. So one example of that is we've got flag updates on reads loads. And then another example, actually maybe even stores, I should double check that. Nope, okay. Anything else that seems like it could affect it? Obviously the sets do, obviously the branches. Well, maybe not obviously. BCS, okay, JMP, okay, good. All right. So that's one thing, and then the other thing is the way that I'm doing the flags manipulation is a little bit silly. And then the other ones, actually also the register name manipulation is not really ideal either. Is this where AWaggle runs out of time due to redesigning his code multiple times? I mean, probably. But I should be able to express this better, right? Like, look at this Garbo here. The only difference is like, oh, this affects this, this affects this, this affects this. So the problem is that the closure can't capture the argument. So I could just grab the referenced thing in this match reg name and then pass it into the closure, but the closure can't capture arguments. Otherwise, it won't be a function pointer. So I think I need to bring back an argument to the function. And the question then is, how do you extract? I guess you can't, huh? So let's match ufun. Or no, not ufun. Let's just match uop. Let arg underscore arg equals 0. Oh, that's a comma. All right, so now what we're going to do is, if it's something that takes a register name, which is read to arg equals reg name, or fetch to, or write, or push, we'll pass it in. And then for the flag stuff, branch set flag arg equals flag, branch clear, set flag, clear flag. Is there a way to, well, and then we obviously do arg. And then I need to modify all of these to take an extra argument, underscore u8, which yes, I did just take this out. Don't at me. Yeah, rude. I almost was like, yes, and then I realized that I was a dum-dum. Go, 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 go. This is actually where AWaggle runs out of time due to not using search and replace to replace things. It never seems to occur to me until I'm almost done. Expected closure that takes one argument. Yeah, I know why. It's right here. Expected two parameters. Oh, it's in here. Yeah, okay, that makes sense. Just trying to get back to where I was. 172, no op. $154, another no op. Basically just didn't update any of my no ops because they don't do anything anyway. Clear flag not found in this scope. Oh. Yeah, fair. Just gotta do like growth and go. expected enum found integer. Huh? Oh, as you ate, that's why. That's not quite right either, because the register names don't map, even though the flags do. But whatever, for now. I'll fix that in a little bit. I've had a couple of thoughts about what I want to do there, but okay. This time it's tea. It's too late for more coffee. Okay, so now that I've done that, I want to pick one that's easy and just kind of fix it up. I don't think there's like a try into for enums currently, which is sort of annoying. Oh well. Alright, so we're gonna pass in the register name, and then we're gonna do CPU reg name as you ate, except that doesn't work. I kind of want to do like an any thing here, but that's bad. Size, right, this is where I run out of time because I redesigned my code 100 times. What I really want is I want to be able to pass in either a register or a flag. Alright, let's just do the thing that I was going to do. Alright, we're just going to assign a number to each of these registers. We're going to refer U8 this guy. So we certainly will not end up with more than 256 registers. Whew, boy. I can feel myself going to sleep. I can only imagine this is not great screen content, but whatever. And then on the CPU, which we implement way the hell down here, let's do one right here. Get reg by number and self, reg num u8, u8 I guess. Make sure that builds correctly. Nope. Oh yeah, I vaguely remember this being an issue. This won't work either. Wonder if you can use into. Probably not. Nope. Maybe we can from? Probably not. That's probably not free either. Fun calls are not allowed in patterns. Well, why the hell not? Alright, fine. Just do it manually for now. Comments. Definitely going to complain about that on the Rust Discord later. Okay. S is already a U8, so that's easy. P, A, X, Y, 5, 6, 7, 8. To the left. Take it back now, y'all. ABL. ABL. Wait, did I? Yeah, I did split that one. Couldn't remember. 10, 11. Okay. And then what we're going to do is okay, so this is what we were doing, right? So we're going to do let regnum equal regname as U8. And then we're going to return CPU regnum. CPU.get reg by number U8. Oh, okay. That's not going to work now. Yep, thought that might happen. Mutable. What's going on here? Consider giving this closure parameter a type. All right. Not a value. That is true. I don't know why I thought that was going to be okay. Okay. Expected mute U8, found U8. Consider dereferencing here to assign to the mutable borrow piece of meta. Yep. Whoa. Fair enough. Go, baby, go. Hey, we made it all the way to A9 again. That's great. So now, let's go ahead and frag this. Do the same thing for basically everybody else. Except this one's going to be ab instead. Yep, still A9. Good. Boop, boop. CPU dot get reg by number regnum. Quickly close the limiter. Fair enough. Whoops. Yeah. Okay. That's obviously wrong. CPU regnum. And then you're gonna tell me I need to dereference it, probably. Expected from the pointer. Oh, it shouldn't have been. Yeah. Okay. Obviously. Second mutable borrow. Just not my intention at all. Wait, hang on. Second mutable borrow occurs here. First borrow later used by call. Okay, fine, fine. Let val u8 equal cpu.get reg by number regnum. And then we'll set this to val because u8 is copy. This should just work. And that needs to go like that. Not a value because I always do this. It's val. There we go. Go, baby, go. I just noticed that you were programming in a terminal window, not a syntax highlighting text editor. I mean, it is a syntax highlighting text editor. It's just Vim in a terminal. So, it can be both things, I guess. Vim does do syntax highlighting. Exactly. See? Syntax. Highlighted. Also, hi, Nick. How can I get rid of these magic numbers here? They all match these enum variants. Why can't I match on an enum variant as a number? It's driving me insane. Please fix. I think you need to as the enum variant. I tried that, but then it doesn't. It's not like a pattern. So watch. Reg names s as u8. Get this working first, real quick. Is that all good? Looks all good, except that it needs to take reg now, obviously. And then let s equal. Oh no, actually. Let val equal CPU get reg by number regnum. And then this is going to be whoop, val. Okay. Right. So see, I tried to add the enum variant, and it says expected one of colon arrow if or pipe here. It doesn't accept the enum variant as the name. Oh, and then I need to delete all of these things. And that. Yeah, so asing the enum variant doesn't work. I tried that. It seems like it should work. It doesn't work. Because patterns, I guess. I also tried u8 from instead of as, but then it yelled at me for not being allowed to function call inside patterns. So ultimately, I just had it as 4, which is obviously bad. I could macro it, I guess, maybe. I'm not really sure how that would work exactly, but... Uh-oh, invalid register number. What happened? Someone set up us the bomb. Push. When am I calling push? PCH and PCL, which I guess I didn't like here, because you can't get a mutable reference to them in this format, which does kind of make sense. Why is the first CPU register 4 instead of 0? Well, it's supposed to be that PC is the first one, but you can't do that because PC is U16, not U8. But I basically access PC as chunks more or less everywhere. So probably I should just fix that and split it into PCH and PCL, and then this would be easier to deal with. Do I actually use reg names PC anywhere? Nope. So okay, let's just do that then. PCH U8 PCL .PC. Self.get PC. Fetch byte needs to do this a little bit more complexly. If self-regs PCL is equal to FF, self.regs.pch plus equals 1, self.regs.pcl is equal to 0, else PCL plus 1. Okay, so that's easy. Get PC just needs to glue these things together now. PCH left shift 16, or PCH as U16, left shift 16. And then regs PCL as U8, or no, as U16. And then where else do I reference the PC? I reference it here. Sure. H L right shift 8 as U8. And just as U8. Where else do I manipulate the program counter? That's get PC. Basically do all this junk already. PCL as U16 plus IDL as U16 will give you this, and then what you want to do is if this is not equal to 0, then you're going to want to do PCL is equal to tempc as U8, PCH plus equal 1. And then in this case, it's just going to be PCL equals this as U8. Oh, and then we have to do exactly the same thing here. Woohoo! It literally is exactly the same thing, so I'll probably just yank. Boop. And then same thing here. Any other references to the PC? Well, there's here, but that's just a debug statement. Just get rid of it. Copy pasting the root of all evil. Yeah, I'm working on it. Alright, so what's... Yeah, I think the best thing you can do is have a function convert a U8 to an option to your enum, and since you're panicking anyways, you can unwrap it. There are crates to derive that conversion. Yeah, that's pretty much what I figured. I feel like that should be auto in place for enums that have this explicit discriminant format. This should be like an as, or a try into should just be auto implemented, or try from. Alright, so this is easy enough. CPU.regs.pcl equals CPU.idl. CPU.regs.pch equals this chunk here. Except probably that needs to happen first because it's the actual fetch. And then we'll get rid of that. And then we'll be good. And then that's get PC. Okay, that should be everything. Nope, not everything because I screwed it up. CPU regs. I don't know about auto-implemented, same as debug. Debug should be auto-implemented for every structure, honestly. It'd be nice to have the drive macro standard. I agree with that. I would be satisfied with that. Close delimiter possibly meant for this. Okay. Oh, yeah, okay. I can just delete that. That makes sense. Attempt to shift left with overflow. Nuh-uh. Oh, okay. Yeah, huh. Good catch. Rust. Oops. Doo-doo-doo-doo-doo. Okay, we're still getting an invalid register number, which is fine. Now we want to do to mute self.regs.pch 3 mute self.regs.pcl. And there we go, invalid instruction A9. Okay, so that clears that up. Now I need to fix some other ones that are unnecessarily duplicated. I think probably the flag ones next would be a good choice. So let flag num equal flag as u8, CPU flag num, return CPU.regs.p or equal flag num. Extremely easy. You never mean for me to give a closure parameter a type, Rust. It's never been that, ever. It's always that I have an extra thingamajig. Okay, and then this is exactly the same, except that it's and not flag num. Oh, and I need to delete these. Okay. Choo choo choo. Alright, this should be the last one. Let's fix these branch and clear and junk. Okay, so I've got the flag. Alright, let flag num equal flag as u8. And then what we want here, drop those, drop this, get this out of here, replace this with flag num, which we pass into the closure. Now that should work, right? Yep. Okay, so how do we combine these two things? Now that we've got that right. What's the difference? The difference is only whether the flag is set or not set. So maybe for branch clear, this is equal 0, that is not equal 0. It's also and does the not thing. What am I trying to say? Jesus. I'm really starting to be flagging here, folks. I'm making this too complicated. I should just do the condition outside, actually. So for branch set, it will be let concode equal flag is equal or CPU.regs.p and flag num greater or is not equal to 0, 1, 0. Rust doesn't actually have those. So it's got to be if that this else this. And then what we'll do is if const code is not equal to 0. And then this will be exactly the same thing. Just copy that. Delete that. And the only difference will be so that is true if what exactly? P and not flag num is 0. What? I think I just had this implemented entirely wrong before. There shouldn't be a negation. Right? You just AND it with the flag number, get the state of the bit, and then if it's not 0, it's set. If it is 0, it's clear. I don't know what the hell I thought I was doing before. Surprised it ran as far as it did. Not found in the scope. Is that true? It is true. Tricky. Well, this doesn't really accomplish what I wanted it to accomplish anyway. Actually, you know what? It totally can. Just do it this way. Right, and then we'll just do the same thing again down here. Boop, except it's going to be, oh no, it's going to be the same, except the con code is going to be 0. And we can get rid of this. No, we still do that. No, that doesn't quite work either, does it? Because I would need to pass 2 arguments. Thinking too hard about this. Should go to bed, probably. Turns out 8 hours of streaming in 2 days is a lot. I'm kind of tired of it. Not like tired of it, but tired from it, rather. It really is a lot. I mean, yeah, I have a lot of respect for people who do this full time. Although, admittedly, I think it would be easier to stream 8 hours over 2 days if I was playing Super Mario Bros. 3 instead of trying to get Super Mario Bros. 3 to run. But even then, it wouldn't be easy. I have to stop fiddling with this. I know there's an answer. Figure it out tomorrow. I'm just going to undo all these changes. Okay, that still runs. This is also a good time to just like commit some stuff, I think. Which I have not been doing regularly at all, because nobody likes to watch Git management. there anything else I need to add? Doesn't really look like it. Alright, what's my next instruction? My next instruction is A9, which is, I think, LDA? Is that what we said? Oh yeah, the whole reason I started doing this is because I'm not setting the flags on reads and stuff. So, alright, I'm just going to implement a second micro op for fetch and update flags. I can, again, fix that later if I want to by taking another argument. Actually, taking a second argument, which is like a Boolean, would be pretty useful, but I'm not going to do it right now. Just going to duplicate a bunch of code for no particularly good reason. So we're just going to fetch the byte. We're going to assign the byte if loaded equals 0. CPU.regs.z, or no, .p or equal flags z as u8, which I didn't actually write in here, but which I'm pretty sure is a 2. Just go ahead and check this. Yep, z is a 2. Generally, we set if an arithmetic request is 0, and then if I look at this, the negative flag is set if bit 7 is set. So, if loaded and 0x80 is not equal to 0, regs z or equal, or not z, p, flags n as u8, and negative is 0x80, I believe, based on what this said. Yep. Okay. So this is read and update flags. And then fetch and update flags is exactly the same, except that it uses the PC instead of the AB. Oh, looks like I misspelled a lot of things. There we go. Okay, and then that should be good. Oops. Go ahead and run this. Pattern ZNN not covered. What a shock. Fill those in with leave me alone values, and then we'll run to A9 still, but we need to fill in the instruction. Then we'll be good. LDA, which one is A9? LDA immediate. And that should run past A9, hopefully. Nope, invalid register number. Interesting. Oh, and fetch and update flags X. Interesting. Why did that happen? That worked before. What happened? Alright, let's just run this with the backtrace and see what happened. Okay, let's see. I really wish, as long as I'm complaining about Rust, we could get some sort of like print me a backtrace but don't make it look stupid kind of a thing, so that it doesn't fill up with like all the panic handlers, which I absolutely never care about. Getting register number 0. Why are you doing that? Stop it. Oh, well, that might have something to do with it. No, it doesn't. Alright, so what's going on? Fetching to register X, getting register number 0. Why the hell is register X as U8 being 0? Oh, right. That's such a bad solution to that problem. I really gotta fix it. Figure it out later. F0. Is that correct? A9 F0. Yep. And it's branch equals. It's an hour and a half. And okay, I can do another half an hour. Okay, so branch equal 1 and F0. I mean, there's only one branch equals. It's going to be very similar to my other branch if flags instructions. It's just that the flag is going to be 0. Okay. So all we should need to do here is add the constant right here. Times F0. Copy the BCC opcode map, branch equal, flags is Z. And then that should just work. Panicked at explicit panic. Oh, yeah, I know why. Because the only difference between this and that is the flag. What a pain in the butt. Actually, I can just make this work. This is fine. Let flag num equal flag as U8. Get rid of that. Get rid of that. Get rid of that. Kaboop. Get rid of that. Take flag num. Flag num. just because I didn't end up being able to unify set and clear does not mean that it was not valuable to do the number thing. Gonna just go ahead and scrub those. Don't need that. Don't need that. Magnum. Also, I think this is wrong anyway. Alright, invalid instruction D0. Is that the next one? Probably. Where was I? I did branch equal. Just right here is F0, more F0s, FCs, A9s, D0. Branch not equal. Equally easy. And it's D, I believe? Yep. Easy peasy. I might actually have this backwards. If the zero flag is set, yeah. So I don't know why I did it that way. Or why it worked. It's troubling. Valid instruction 85. This probably means I'm broken twice. Because I don't think, oh no, 85 is the next instruction. That's weird. Oh, it was broken twice. Yeah, okay, this is fine. Okay, 85 is another store arithmetic. Or store accumulator, rather. And it's not another, it's the only one that I've done so far. But I did store X, so it should be just fine. Store X 0 page, 85. I'm just gonna go ahead and take that, paste it up here. That becomes an A. That becomes an A. That becomes an A. Go, go, go. 24. Yep. Bit. Bit tests. Use to test if one or more bits are set in our target memory location. The pattern, mask pattern in A is ANDed with the value in memory to set or clear the 0 flag, but the result is not kept. Bits 7 and 6 of the value from memory are copied into the N and V flags. Okay. That's kind of a weird instruction. Shouldn't be too bad though, I guess. Bit ZPG is 24. Let's pull it up in here. Uh-oh. Let's match case, shall we? 0 page addressing. Yeah, I mean, I guess it's basically the same. Fetch opcode, increment PC, fetch address, increment PC, read from effective address. Oh, those are immediates, no wonder. I was looking at totally the wrong thing. I don't actually have any 0 pages set up. It's going to be basically just this, except ABL only. So let's go to bit CPG, fetch to AL, and then read to is going to be replaced by test. This one actually does need to be a new opcode. Are there other versions of bit? I don't think there are. It's not like a Bix. Nope. Okay. So we need to implement this micro function bit or test yields you a weird thing. CPU underscore parentheses. This is some real programming shit. What do you mean? Pouring hot tea on your face. This tea is cold now, sadly. Ugh. And not good. It's very not good because it's cold. Okay, how does bit test work? I was just looking at this 2 seconds ago. Okay, so CPU dot regs dot p temp p CPU dot regs dot p and 0x 3f CPU regs p is equal to temp p for I need to actually fetch the thing, huh? Should be relatively easy. Do this, except it shouldn't be fetch, it should probably be get. What am I looking at here? I want read. Okay. Loaded and 0xc0. And then if the mask pattern in A is ANDed with the value of memory to set or clear the 0 flag. Okay. So let's go ahead and splice the 0 flag out of this, which makes it not an F but a D. And what do you mean this is some real programming shit? I'm still curious about that. I guess there's lots of bit twiddling. Okay, so I slice that out, so it's that, and then if loaded and regs A is equal to 0 to 0. Or 0. I'm not a full stack JavaScript developer. That is true. I am not that. I don't think there's anything particularly wrong with being that, but currently I am not. Yeah, I've done a lot of different stuff, but none of it's really been JavaScript. I tried to learn JavaScript a couple years ago because I badly needed a job, and that seemed to be what was hiring, but I ended up getting a different job, so that worked out. Interesting. Why are you upset with me, friendo? Bit 01 equals F. DVS. Oh, okay. It's because it's not immediate, actually. This is a PC load. I need to get rid of this right now because that's not self.get PC. And then this one would actually be, do I want, is it supposed to increment? Hang on. I mean, I guess it would increment, right? Because that it wouldn't make sense otherwise. And if we look at this, it says fetch address increment PC. But why do you say doing something wrong here? If one or more bits are set in a target memory location. Okay, so I am actually doing things wrong here. So if I go and look at the bit code that I'm passing, I'm fetching to ABL. So I do actually want to load from AD. I want it to be a get byte, not a fetch, but it shouldn't really matter, I guess. And then my load is failing because I am not accessing things correctly, which totally makes sense. Okay, let me just fix all these fetch byte calls. And then I'll fix that. So many calls that don't make sense. There we go. Okay, so this should be get byte. Okay. Of course, it's not AD, it's AD. Dang it. Choo 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 choo. Right, and then you fail because you're trying to load from the 0 page and I haven't implemented it. Okay, yeah, so this is if batter is greater than or equal to. Yeah, equal to 0x4020. Pass it to the mapper. Else, assert address is less than, what's it supposed to be again? CPU memory map 2000. Adder and 0x7ff. Return self.ram effective adder. And actually, I don't even need to return it. It will just fall out like that. Go. Nope. Oh yeah, usize. Choo 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 choo. Don't explode. Hey, it didn't explode. Invalid address, or invalid instruction 70 is BBS. I feel like this is really flowing pretty effectively at this point. Branch if overflow set, so that should be easy. BS is 70. Just take B and E, turn it into B, BS. Flag is V for overflow, go. And there is no overflow flag right now. So let's just go ahead and do it. V, I think you're 4. Where'd it go? Okay. Okay, so yeah, I was right. V is 4. And so this should run past that instruction. So nice when all this groundwork that you laid actually sort of pays off and sort of does the right thing and makes certain things a lot easier. BVC is just overflow clear. So yeah. Oh, actually BVC is what I already implemented. And BVC is 50, I believe. Yep. Oop. Go. Valid instruction 10. That's fine, that's fine, that's fine. It's fine, 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 fine. Instruction 10, BPL. What is BP? Branch if positive, so if negative, flag is clear. Okay. And that's 10. So again, just is this flag clear, but with BPL, and the positive flag, which I think is a P. Is that right? Let's see here. Oh no, of course, the positive flag is just the absence of a negative flag. I literally said that out loud to myself not a minute ago. 60. Whoop. Nope, don't do that. That would be bad. Okay, there we go. Uh-oh. 60's returned from subroutine. That seems complicated. Where is the stack trace? Is that what I'm actually supposed to hit next? BPL, BPL, jump, no op. Yep. All right, return to sender it is. This will be the last implementation for today, I think. So I suspect it will be complex, at least to some extent. Let's pull up this bad boy. Actually, maybe it won't be that bad. Let's get some of these out of there so I can look at the instructions and the code simultaneously. Okay, so we did JSR. Now we're going to do RTS 60. All right, here's JSR, so let's start with that. Go to RTS. All right, so step 1, fetch opcode increment PC. Fetch next instruction byte and throw it away. Okay. Okay, so fetch opcode is actually the previous instruction. Read next instruction byte and throw it away, technically is what this will do. Increment S, okay. Don't have that implemented, can do it pretty easy. Poll. PCL and then PCH. And And then that just says increment PC. Interesting. Is that right? That really doesn't like make a ton of sense. I feel like this is someone not totally understanding how a stack works, honestly. Much more likely would be that it's just fetching differently than this guy thinks it is. But maybe not. I don't know. What do I know? A lot of things, actually. But and that says read next instruction byte and throw it away, which makes sense because you pull PCL from stack and PCH from stack. And then you increment the PC. That's a weird instruction, honestly. I mean, I guess it makes sense. Kind of. Sort of. Not really. Alright, so we need to implement increment. RTS does say 6 cycles. Yeah, but like it's a weird layout of 6 cycles according to this document, which is what I'm sort of skeptical about. Like, why would incrementing be separate and then there's a pull and an increment on this cycle and then another pull and then you increment PC? It's very strange. I mean, yeah, it could just be the 6502 being weird. Also, shouldn't you be asleep? Isn't it like 1 a.m. where you are? Oh, I guess it's only 11:30 where you are. Yeah, I thought about Visual 6502. I saw it referenced on the front page of the wiki. I've actually seen it before because it's a very cool project. Maybe I will get around to looking at that. So I need increment and I need pull. And then we're going to go up here. It is 11:35 in the evening, but don't you have school tomorrow, little boy or girl? I still have no idea. Alright. Pull. This is basically the same except we use get byte instead of set byte. So we're going to do CPU get reg by number equals get byte CPU regs s as u16 plus 0x100. You know what? This is my last thing for today. Maybe I will look at Visual 6502. Just for fun. I think it would be more interesting. I thought that this was linked from here somewhere. It probably is, but I can also literally just Google it. Oh, there it is. Okay, this is probably a MOS 6502, but that would be more complicated. Let's just do this. Uses HTML5 features, use the latest RAM, more information in the user guide. Alright, so you can pan and zoom the chip's graphics. You can click run. Whee! How can I take a break? Oh, I guess I can just step it. Because that 60 is an RTS. Okay, so this is the 60. Stream did not like that. Oh, is it dying? That actually makes total sense because this is probably eating up all my RAM. Video quality is hurting. Okay, fair. Fair. Let me just, Alright, I'm not gonna bother with this, actually. It is very cool, don't get me wrong. But it just, requires more time than I really have to give it right now. So, I mean, it only makes sense. I'm going to increment, yeah, here's what I'm going to do. I'm going to increment before pulling. I think that'll match this, right? If we look at this thing. If I put a no-op right here and I increment before I do pull, it'll look exactly the same. What was that colorful image? It was Visual 6502, which again is going to destroy my stream, but it's a JavaScript simulation of the actual transistors that make up the processor of the NES. And so if you want to know exactly at the level of transistors what happens during a particular instruction, you can step this through by like half cycles of the clock and see what all bits toggle. And that way you can figure out exactly what's going on. It is absolutely overkill for the purposes that I am currently engaged in, but it's super cool. Yeah, if I just increment twice. Yeah, circuits are complicated. Turns out silicon circuits, this is all like multiple layers of silicon, P and N doped semiconductors, wire layers, blah, 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 blah. Just integrate Visual 6502 support in your emulator. You know what? If I wanted to do that, I would just buy or build a Monster 6502 and sit it on my desk and be like, look at this thing I made. Actually, I would never build one myself. I'm well past the point of wanting to solder that many transistors. Okay, yeah, so I'm just going to pull twice. Instead of an increment here, I'm just going to do a no-op. Pull twice, and then we'll bump the PC, I guess. Honestly, still seems kind of weird to do that, but whatever you say, friendo. What does the push instruction actually do? So JSR. Oh, I get it. Okay. It's because when it pushes the address to jump to is still in front of the PC, so we need to push it one more time. That makes total sense. All right. Microphone. I'm going to call it step PC instead because it's going to need to do some slightly weird things. Alright, let temp PC equal CPU dot regs dot PCL as U16 plus 1. If temp PC is greater than FF, CPU dot regs dot PCH plus equals 1. CPU dot regs dot PCL equals temp PC as U8. Actually, that's true either way. So let's just do that. Okay. And then I didn't declare it, so let's just go up here and change increment. Is that language unique to the NES? Which language? The 6502 thing? That is the specific processor of the NES, certainly. Okay, I just mistyped something somewhere. Oh, yeah. Sorry. Didn't think at all. Everything I'm doing. Yeah, well, okay. That's a complicated question, depending on how seriously you want to take it, I guess. It is... Like, I am doing specifically an NES emulator. A lot of the skills required to do an NES emulator, air quotes, an NES emulator are transferable to doing other kinds of emulators. The specific CPU that I'm implementing right now, as Sai correctly pointed out after I misspoke, was used in a lot of different things. So that is not unique to the NES. This language that I'm writing is Rust, which is certainly not unique to the NES, and in fact did not exist when the NES existed. Well, that doesn't seem right. So it kind of depends on what specifically you mean. So that doesn't seem right. When was my jump to subroutine call? Way back up here. So we should have put like C5FF. But we ended up with CFFF somehow. Alright, so I'm just going to print the register number and the result. So that I can check what is going wrong here. We are getting FF twice. Doesn't really make sense. CPU.regs.s as U16 plus 0x100. Yeah, I'm definitely well past the point I should have gone to bed. I'm sure this is going to be very dumb when I figure it out. There we go. Turns out if you don't update your stack variable, then your stack doesn't work. Okay, so the RTS is like right here, I think. Is that right? Okay, so I should be ending up well, I guess a bunch of stuff happened after that, huh? Do you have to master the languages with which NES was made, or you can bypass it with just modern languages? You can write an emulator in any language you like, but you have to write the emulator for the assembly language that the NES was programmed with, or technically for the bytecode language that the NES assembly was compiled into. So, I mean, there have been NES emulators written in JavaScript. There have been NES emulators written in Lua. This is not the first NES emulator written in Rust by any means. You can write it in any language. But you do have to understand the language that the NES sort of speaks, for lack of a better term, in order to be able to emulate it correctly. Okay, so it looks like this ran for quite a while until it hit SEI. I should go to bed. I should stop while I'm ahead. That was 2 hours of streaming. That's plenty. Okay. Did that answer your question, Gustavo? Thanks for stopping by the way. You don't seem to have come from the emulation Discord, which makes me happy. I appreciate you stopping in, and I hope that you will come back. I'm hoping to do about an hour a night for this week, and then back to doing probably 2 2-hour chunks a day, Saturday and Sunday of next weekend. So, I don't know, I think this is the part where I'm supposed to tell you to follow me or something, but honestly, if you don't want to, you don't have to, it's fine. Well, thanks everyone for coming and checking this out. We made some good progress today, really kind of chewing through the CPU instructions. Hopefully I can get that finished over like tomorrow, the next day. Yes, like, follow, subscribe. Smash that like button. Yeah, so hopefully I can finish up the CPU instructions over the next couple of days, and then we'll get into the graphics side of things, start implementing the PPU. So the goal of this, for those of you who maybe came a little late or I haven't said it for several hours, is to write an NES emulator that is capable of running Super Mario Bros. 3 in 2 weeks or less. That includes graphics, but sound is optional. This is a bet I made with Sai from the emulation Discord, and there's really no stakes other than nerd cred, but that's what I'm going to try to do, and I'm going to stream it because, well, it's fun, and I haven't done streaming in a really long time. So thanks for checking everything out. I'll see you tomorrow, hopefully. If not, I'll catch you some other time. But have a good night, everyone.